Welcome to the Standing Waves on a Spring video. In exercise 1 of this experiment, we'll be examining the normal modes of a spring to determine its linear mass density.
To start, set up the apparatus as shown, with the mechanical wave driver located directly below the bar. Use a reasonably long spring to start to ensure that you can see as many nodes as possible. It is advisable to tape the end of the spring to the bar, the hook to the driver, and the driver to the table.
Turn on the function generator. Starting from a low frequency, turn up the amplitude until you can see oscillations. Most people find it easiest to start by increasing the frequency until they locate a single node. From there, you can divide the frequency by 2 to get the fundamental and work upwards to larger numbers of nodes. Here, you can see a single node where a small part of the spring remains stationary despite the motion of the surroundings. You will want to record the frequency of each resonant mode. Note that there will be a range of frequencies where each mode is visible. Record this range to establish an uncertainty on your resonant frequency. Note that the analysis will ask you to find the spring constant using an old method as well. See the damped mass on a spring video, exercise 1, for one such method.
In exercise 2, we'll be changing the length of the spring and correspondingly the tension.
Adjust the height of the bar. Ensure that there is still some tension in the spring. Measure a particular mode's frequency for various lengths of spring. Find the spring constant and compare to your previous results.
In exercise 3, we'll be repeating experiments 1 and 2 for a different spring.
Replace the spring with one that is stiffer. Repeat the same measurements you made in exercises 1 and 2, but note that this time you'll be creating one plot as a function of resonant frequency and one as a function of length, each of which will be used to determine the linear mass density. Compare these with each other and the theoretical linear mass density obtained from a balance and meter stick. I have been reading of Schrödinger's cat, but none of my cats are at all like that. This unusual animal, so it is said, is simultaneously live and dead. What I don't understand is just why he can't be one or other, unquestionably. My future now hangs in between eigenstates. In one I'm enlightened, the other I ain't. If you understand, then show me the way, and rescue my psyche from quantum decay. But if this queer thing has perplexed even you, then I will and won't see you in Schrödinger's zoo.